So now that we know where electrons are located in the atom, we can draw something called an orbital diagram. An orbital diagram just shows where the electrons are in an atom. So let's pick an atom, something with not too many electrons. So let's pick oxygen. Now if I look at the periodic table, I'll note that oxygen has a mass number of about 16, and it has 8 protons. Because it has 8 protons, if it doesn't have a charge, so we can see I did not give this oxygen atom a charge, it also means that it must have 8 electrons. To draw the orbital diagram, we have to think about all of those rules we had on the last page. So the first rule we have to think about is the Aufbau principle, which states that electrons fill low energy levels first. So the first energy level I have is energy level 1. And in this energy level, an electron must be in a sublevel. And if you remember, the first energy level only has an S sublevel. So energy level 1, S sublevel. The S sublevel has 1 orbital, and I'm going to represent my orbital with a box. So if we add electrons to this, well, oxygen has 8 electrons, so we'll fill in the first electron, and now there's no other orbitals in this sublevel, so the second electron for this orbital must go in the same box. So we've used up 2 electrons, so we have a total of 6 left. So what do we do now? Well, first energy level is filled, so we must go to the second energy level. And the first sublevel that exists in that sublevel is the S sublevel again. And since it is an S sublevel, it only has 1 orbital. So in this orbital, we'll put the electrons. 1, 2. One is spin up, one is spin down, according to the Pauli exclusion principle. And that's going to leave us with 4 electrons left that we have to put in our picture. So where do these 4 electrons go? Well, in the second energy level, we also have a p sublevel. And that p sublevel has 3 orbitals. So instead of just 1 box, I'm going to draw 3 boxes. So we have this p sublevel, and we have to put in 4 electrons. So I'm going to put in 1 electron here. Now the second electron, remember that electrons don't like to share boxes if there's other rooms, so the second electron will go in the next box, the third will go in this one, and then because there are no more rooms in this sublevel, the fourth and final electron will go back in the first box, but it will have the opposite spin. And this is our orbital diagram for oxygen. And if we count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8, it's the same as the number of electrons that a neutral oxygen atom should have. So now let's do one more, and you can try this on your own before we go over it. So let's do the electron configuration for bromine. And bromine has 35 protons, meaning in a neutral atom it will have 35 electrons. So give that a try on your own. In a second I will show you how to do this. Okay, so now let's look at the answer. So we need a total of 35 electrons. So I fill my 1s, then I go to my 2s. That's filled, so I need my 2p. After 2p, there's no d or f orbitals in the second energy level, so I need to go to the third energy level, which starts with s. Then I go to my third energy level p sublevel. And now if you notice, well, the third energy level should have Ds, but I go to the 4 S's. After I go to the fourth energy level, I then go to my 3Ds. I basically go backwards to my 3Ds. And finally, I get to the 4 Ps. Now, why does this happen? Why do the Ds actually come after the 4 S's? And to explain why, let's look at the diagonal rule. In the diagonal rule, you list your orbitals by both energy level and sublevel. So in the first column, I put the S sublevels 1 through 7. The second column, all the P's, the D's, and the F's. And notice that each one starts one energy level later, according to the rules I showed you before. Now, if we draw a diagonal line through each row, you can find the order that the electron's orbitals fill. So you start the 1 S's, the 2 S's, then the 2 P's, the 3 S's, the 3 P's, then the 4 S's, 3D, 4P, 5S. Then you actually go back again after the 5S, then you go back to the 4D, and so on. Now before we move on, and I'll show you an even faster trick to remembering how to write these orbitals, we need to talk about the electron configuration.